All right, so let's get into our examples using graphs here. And here, you'll notice there's a plus sign on this limit and a minus sign on this limit and no sign on this limit. I want to start by clarifying, in case you haven't seen these or you've forgotten, that this is a one-sided limit. This means as x approaches 1 from the right. That's how we read it out loud. And it means like when x equals a number that's just a tiny, tiny bit bigger than 1. Okay? When we have x approaches 1 with a minus sign, the way we read that is as x approaches 1 from the left. And notice that this is not a negative 1. It's still a positive 1. The negative sign is not in front of the 1. It's after it. And it's only used in limits, really. And it means when you're just a tiny bit smaller than 1. So like when x is 0.9999. And the last thing is, if it doesn't say from the left or from the right, this means from both sides. And if both one-sided limits are the same, that is the limit value. If they are not the same, so if the left and the right limit are not the same, the both sides limit is undefined. And we'll see that in just a second. So hopefully we feel familiar with this already from pre-calculus, but this is a one-sided limit. It means either you're approaching the number 1 just a tiny bit bigger than it, or you're approaching the number 1 just a tiny bit smaller than it. And the overall limit means approaching from both sides. So let's see how this plays out in graphs. So this first one, this is the limit as x approaches 1 from the right. And it means when x is just a tiny bit bigger than 1, what is the y value getting close to? And so let's look. When we're just a tiny bit bigger than 1, the y value is getting really close to 3. And we should see that because as you're getting closer and closer and closer to 1 from the right side, the y values are getting close to 3. As you're getting close to 1 from the left side, that's what this next limit means. As you're getting close to 1 from the left side, I see a hole here. But we're not actually asking what is happening at x equals 1 where there's a hole. It's what happens when you get really close. So the fact that there's a hole here does not affect this limit. As we get really, really close, the y values are getting really close to -1. And finally, the overall limit, because it doesn't say from the left or the right, it means from both sides. So what is the overall limit here? Well, it's undefined. I'm sorry. We should not say undefined here. I apologize. This is my fault. Bad terminology. When a limit is different from one side to the other, the limit is said to, it does not exist. A function value is undefined. A limit does not exist. I really apologize. Does not exist. All right, so I'll be making that distinction. Limits, when the limits are different or they don't approach a single value, we say they do not exist. Sometimes we'll write D and E for that, and that's fine. The limit does not exist. Finally, f of 1 means when x is exactly 1, what is the y value? And when x is exactly 1, for a function, there will only be one output. You'll notice that there's a blank circle here and a filled-in circle here. This is the y value when x equals 1, and this is not the y value. So the y value when x equals 1 is 3, and that's what we mean by f of 1. So let's see how you do on this. Let's see if you can feel okay about this. What does this say, first of all? This says the limit as x approaches 1 from the right, and it means if x is just a little bit bigger than 1, what's the y value getting close to? And so when x is just a little bit bigger than 1, what is y getting close to? The y value is getting close to 3. It doesn't actually matter that there's a hole there because the y's are getting close to 3 when the x's get close to 1. What about this one? What does this one say? This is the limit as x goes to 1 from the left side. And so as we come in from the left, what is the y value getting close to as we get near 1? Well, that limit value is also 3. The y value is getting close to 3 as x gets close to 1 from the left side. And finally, the overall limit means what? Hopefully we understand that it means the limit as x approaches 1 from both sides. So is the y value getting close no matter to the same value no matter which side we come from? And the answer is yes. Because these are the same, we know that the overall limit is getting close to 3. The last question is, what is f of 1? So what is the y value at 1? Well, at 1, the y value is not 3. There's a blank circle there. The y value is 1. And so these are different. Sometimes they're different. Sometimes they're all the same. Here we saw 3 different answers and the same answer, and we saw a different answer here from any of these. That's all okay. If we understand the meaning, this should make sense. Okay, so read this out loud to yourself in your head, and you should understand it says the limit as x approaches 1 from the right side of f of x, or we can say the limit of f of x as x approaches 1 from the right. And that limit is 3. As we come in from the right side, the limiting value is 3. Again, we're not talking about what happens at 3, so it doesn't matter that there's a blank circle there. We're saying what happens when you get really close. When x gets really close to 1, the y value is getting really close to 3. Coming in from the left side, as x approaches 1 from the left, the y value is getting very close to 3 as well. As we get really, really close to 1 from the left side, the y values are getting very close to 3. And so the overall limit is 3 because the 2 are the same from both sides. All right, what about f of 1? F of 1 means what is the y value when x is 1, and now there is no point here. This does not exist, and I want to clarify here. I apologize for messing this up earlier. This is an undefined value. So when we talk about function values, and there is no function value there, we say it's undefined. When a limit doesn't have a value, we say the limit doesn't exist. So whenever you have function values, it'll be defined or undefined, and either a limit will have a value or not exist. Okay, last, we have a continuous function. So what is the limit as x approaches 1? Well, as x approaches 1 from the right, the y values are getting close to 3. As x approaches 1 from the left, the y values approaching 3. As x approaches 1 from both sides, which is what this means, the y value is approaching 3. All the y values are approaching 3. And what is f of 1? Well, f of 1 is 3. And so, okay, this is kind of boring. They're all the same, but this is actually incredibly useful. And the really nice thing about this is that whenever we have a continuous function with no breaks, the limit and the value are the same. And so let's say we have a function like f of x equals x squared. We know what this looks like. F of x equals squared makes a parabola. And there's no breaks in this. We know that when x equals 3, f of 3 equals 3 squared, which is 9. And because it's continuous and because there's no breaks in it, we know that the limit as x approaches 3 from the left, as you come in from 3 from the left side, the y values are going to get close to 9. Same with the limit as x approaches 3 from the right side, the y values are going to be 9. And the overall limit as x approaches 3 will be 9. And so for all continuous functions, if you know the y value, the limit will be the same as the y value because there aren't any breaks or weird things going on. And so that's a nice thing to know, that they can all be the same if it's a continuous function. And we'll talk about that more later this year. Okay, your turn to try some things. And you'll get to skip over quite a bit of, as I'm going to try to make all year long while we're in virtual learning, you'll get to skip over quite a bit of these if you get the right answers, because you don't need the explanations. Is this a function? How can you tell? So is this a function? How can we tell? Well, functions have no places where the y values where for a single x value there's more than one y value. We can use the vertical line test, and we can see that at every x value there's exactly one y value. Even places where it looks like there might be two, only one is a filled in circle and the other one is a blank circle. It doesn't matter that there are places missing here. It's still a function. Yes, because for each x there is only one y value. Okay, what type of function is this? We should be aware of what kind of function this is. This is called a piecewise function. We'll be talking about them later in the year, how we do them with calculus. They're not hard, but there are a bunch of different pieces. I count 1 piece, 2 pieces, 3 pieces, 4 pieces, 5 pieces, 6 pieces, 7 pieces. Even though these are connected, it's not the same kind of function. This is a linear function and then some sort of like cubic function or something. So it's a piecewise function, and we'll talk about how to deal with that with calculus later. Okay, how do we read this? This is the limit of b of x as x approaches -4, or the limit as x approaches -4 of b of x. Both are acceptable. And it's asking us as x gets really close to -4. Notice that this negative is in front of it, not after it. So notice the difference between that and x approaches 4 from this means as x gets close to +4 from the left side, so like 3.999, versus this is what happens when x gets closer to -4 from both sides. So whenever there isn't a plus or a minus, we need to do it from both sides. So as x approaches 4 from the left side, the y value is getting close to 3, and as x approaches 4 from the right side, the y value is getting close to 3. And so because it's the same from both the left and the right, the y value is 3. Okay. How about the limit as x approaches 1 of b of x? So as x approaches 1, again, it's from both sides. So as x gets really close to 1 from both the left and the right side, the y values are getting close to 1. As x approaches 5 of b of x, again, it's from both sides. So as x gets close to 5 from the left side, the y value is getting close to 5. And as x gets close to 5 from the right side, the y value is getting close to 5. And so that overall limit is 5. Here's a slightly different one. How do we read this? This is as x approaches 2, the limit as x approaches 2 from the right of b of x, or the limit of b of x as x approaches 2 from the right. It means when x is just a little bit bigger than 2, what is the y value getting close to? So let's go. Here's 2, and we're just a little bit bigger. We are coming in from the right side, and that y value is getting close to 3. Notice that there's an open circle there, but it doesn't matter. We're just getting really close to it. We're not actually there. And the y values when we get really close are all near 3. What about as x approaches 2 from the left side? This is not -2. This is like 1.999. So when x gets really close to 2 from the left side, what is the y value getting close to? And here, as we come in from the left side, we can see that as x gets close to 2 from the left, the y values are getting close to 2. So what is the overall limit as x approaches 2? Well, as x approaches 2, we need to come from both sides, and we see that from one side, it's getting close to 2, and from the other side, it's close to 3, and so that overall limit does not exist. You can write out does not exist, but it's kind of long, and so a lot of times we'll put DNE for does not exist. Again, we only use this for limits. For functions, we would say undefined if there isn't a value. Okay, let's talk about the definition of a limit. F is a function, and C and L are numbers like 3 and 7. Okay, the limit of f of x as x approaches c is L if and only if. So what do we need for the overall limit to be this? And let's write this in our limit notation. So the limit as x approaches c of f of x, the limit of f of x as x approaches c, is equal to L if and only if, there's a math symbol, IFF means if and only if. You may or may not have seen it before. If and only if, what has to be true for the overall limit to be L? Well, there are two things that need to be true. The limit as x approaches c from the left of f of x needs to equal L, and L also needs to be the limit as x approaches c from the right. So those are the two things that need to be true. And the AP exam, when you are justifying the existence for a limit, on the free response section, when they ask you, what is the limit of something, very, very often, in fact, almost every AP exam, you need to calculate both the left limit and the right limit and say that they're equal to each other, and therefore the limit is that thing. So let's look at an example with these numbers. So for the limit as x approaches 3 of f of x to be equal to 7, what are the two things we need to prove that this limit is equal to 7? We need the limit as x approaches 3 from the right side of f of x to be 7, and we need the limit, and the limit as x approaches 3 from the left side of f of x to be 7. If both coming in from the left and coming in from the right, you get to 7 in both sides, the limit will exist. And notice, we're just talking about what happens when we get close. We need coming in from the left side to get closer and closer to 7, and we need coming in from the right side to get closer and closer to 7. This could be a point, could be a blank circle. It doesn't matter. The limit is about what happens when you get close, not what actually happens when we're there. So this is fine. The limit as x approaches 3 of f of x would be 7. This would also be the limit as x approaches 3 would be 7. And even if there's like absolutely nothing there and no point anywhere, the limit as x approaches 3 of f of x could be 7. All right. So with this in mind, let's see this. Hopefully you guys remember from pre-calculus how to graph this function. I'll let you try that on your own, and if you know how to, you won't need to see this explanation. But otherwise, let's do it. This is a piecewise function, and it's got this rational function. And one of the things we should know about rational functions is we want to factor them and cancel out any holes. So I'm going to rewrite this as, so g of x is equal to x minus 2 times x plus 2. That's how we factor x squared minus 4, divided by x minus 2. And this is when x does not equal 2. And it's equal to 3 when x does equal 2. And we can see that there's a hole when x equals negative 2, but it can cancel out at every place where x doesn't equal to 2. And so, you know, it was already this when x didn't equal to 2, so when x equals 2, it's something else. So this is the same as just the function x plus 2 when x doesn't equal to 2. So hopefully you remember that from pre-calculus or from algebra 2, that we can simplify rational functions, taking advantage of holes, but understanding that when x equals 2, there won't be a point there. So let's graph this. When y equals x plus 2, so the y-intercept is 2, and the slope is 1. So this is a linear function. And it's going to be this graph everywhere except when x is 2. When x equals 2, this function is not defined there. That's what we mean by a hole. Another name for this would be a removable discontinuity. But luckily, it gives us in our definition, it used this when x wasn't equal to 2, and the y value is 3 when x does equal to 2. So that point goes right here. So it's got this like straight line with a hole in it, and at x equals 2, the y value is 3. Okay, so hopefully we feel comfortable with how to graph that. Again, piecewise functions are just ways of saying like at different parts. So everywhere where x isn't equal to 2, we're using this function, and when x does equal to 2, we use the value 3. Okay, so go ahead and answer this on your own. How do we read this? And what does it mean? Okay, and so the limit as x approaches 2 from the right of g of x means when x is just a tiny bit bigger than 2, what is the y value getting close to? And hopefully we can see that that limit, as we get close to 2 from the right side, is equal to 4. So as we come in from the right side, the limiting y value is 4. As we get closer and closer and closer to 2, the y value is getting closer and closer to 4. How about this? As x approaches 2 from the left side, what is the y value? So as x approaches 2 from the left side, the y value we're getting closer and closer to is also 4. So both the right and the left, we're getting closer and closer to 4. And you could check this with a calculator. If you put in like 4.001 into this function, you'd get out an answer that was very close to 4. If you plugged in 2.001, the answer would come out very close to 4. All right, and so what is the overall limit? This, of course, means the limit from both sides And because from both sides it's approaching 4, the overall limit is also 4. What is g of 2? G of 2 is what is the actual y value when x is 2. And so now we're not talking about what happens when we get close. When we're actually at 2, there is a filled in point here, not a blank circle. And so that y value at g of 2 is 3. Notice that it is different from the limit. Okay, let's get into how we can use, you're going to need a calculator for this portion. We are going to, and I'll show you some cool calculator tricks here if you have the TI-83, or you can just plug this in. We do need to be a little bit careful. We want to find the limit as x goes to 0. Okay, and so first of all, how would we write this limit in function notation? We want to write this here. This is the limit as x approaches 0 of f of x. Notice we don't have to rewrite this whole function if the function has a name. And we want to find out what this is equal to. Now, notice they did not say from the left or from the right. So what does that mean? Which one do we use? The answer is, of course, we use both. We need to calculate both the limit from the left and the limit from the right. And the way we do that using a calculator or a table is we're going to plug in numbers that get closer and closer and closer to the left side of 0 and to the right side of 0. Numbers that are a little bit smaller than 0 are like negative 0.001. This is from the left. So this is x approaches 0 from the left. If we're looking at x approaches 0 from the right, it's numbers that are a little bit bigger than 0, and we're talking about numbers like 0.001. So let's go ahead and do this. Go ahead and try to put in these numbers on your own. It may take a little while, but I think it's worth practicing how to put in numbers so you don't get this wrong on quizzes. We do have a quiz coming up fairly soon. So we want to put in negative 0.1 in for x here. And I'll show you a couple ways to do that in the calculator, and I'll let you do some of the other ones on your own. One is just to put it in, and whether you're using a calculator like this or a calculator like Desmos that's online, it should be fairly easy to make a fraction. You just plug in negative 0.1 divided by the square root of negative 0.1 plus 1 minus 1, and we're going to find what that value is equal to, 1.948. By the way, because it's 1.9, I might already be thinking that the limit might be 2. But I want to get a little bit closer to C. So now we're going to do the same thing, and I'm going to go up and select this so I don't have to type the whole thing again. I'm going to put in 0.01, insert a 0 here, and we see this value. And now it's 1.99498. And so it sure looks like it's getting closer to 2. Go ahead and make sure you can fill these out on your own. Go ahead and get those values. You should have gotten that this was 1.999498, 1.9999498, and at some point your calculator actually might round it to 2, depending on how willing to round it is. But we'll notice it's getting closer and closer to 2, and so this is the limit as x approaches 0 from the left of f of x. As we get closer and closer to 0 from the left side, the y values are equal to 2. At x equals 0, go ahead and plug in x equals 0 for x here. And you should have gotten an error. This value is undefined. There is no value here. And by the way, this is actually a form of calculating a slope. Do you guys remember in our first lesson, we were doing a whole bunch of slope calculations that ended up looking kind of like this? We will be able to use limits to not have to do slope calculations anymore pretty soon. So that's why we're learning about limits, is so that we can get rid of some of the ugliness of that first day where we had to use lots of calculators. After today, I believe, we're going to be using very little calculator for a long time. But if you had any questions on calculator stuff, feel free to ask each other or message me if you're having trouble entering things in or having calculator issues. I realize not being in class is trouble. Okay, on the other side, if we're choosing numbers that are a little bit bigger than 1, this is the limit as x goes to 0 from the right. And sometimes, guys, I won't even do 0.1, 0.01, 0.001. I will skip straight to like 0.001 and see what happens. So now we're putting in, we need to make sure it's positive. But I'm going to skip straight to 0.001, 2.001. And if you can tell, like it's 2.000, like, okay, well, I know this limit is going to be 2, right? Like, do I really need to get closer? I can already tell this limit is 2. And so a lot of times we won't actually make a table. We'll just choose one thing that's really close. And if we still can't tell, we'll get even closer to help us out with it. So the limit from the left was 2. The limit from the right was 2. And so the overall limit is 2. Guys, we want to construct a limit as x approaches 2. And so we're going to put right in the center 2. And this is one part you should always do, is you should actually just plug in 2. And when you plug in 2 here, what do you get? You should have gotten that this was undefined. You get some sort of an error. There is no value when you plug in 2 here. And if it ever is defined, you don't need to like do any sort of a limit, because you know that the y value is going to like get closer and closer to this value because there's no break in the function. So if you ever have just a function and you plug in the value, it's called direct substitution. It's a nice way to tell what the limit is immediately. But we need to do the limit as x approaches 2 from the left side and the limit as x approaches 2 from the right side. And this is the limit of m of x. We want to see, does m of x have any sort of limiting value? And so what kind of number is an appropriate number to put in for x approaches 2 from the left side? I'm just going to do the fast way here, and I'm going to say, look, 1.999 is a good number to plug in. And I'm going to skip straight to that because I don't want to type this in a whole bunch of times. I'm going to pick a number that's pretty close, and if I need to go closer, like maybe I can later put in 1.99999 or something like that. But for now, I'm going to put in 1.999. And so I'm going to plug in a number very close to 2 from the left. 1.999 squared minus 1.999 minus 2. So I'm just plugging in this value for x and seeing what the y value is. Oops. And I get 0.333444. This seems a little bit less clear to me what it is than before. It's not going to 0. Maybe it's going to 1/3. I actually might want to go a little bit closer here and see what's happening. So I'm going to put in some extra. I'm going to use the insert button on this calculator. I press second insert so I don't have to type in a bunch of things again. Oh my goodness, I put a letter thing. 999. You do have to make sure you have the same number of decimal places here or it will not work. Like you can't use like 1.999 in one place and different numbers of 9s in another place. That'll cause an error. Oops, see, like this. Check this out. I put 1 point, and I have 5 9s here. I have 5 9s here. What's going on here? 1.99999. 1.99999. You know what I think actually happened? I think I got too close to it. These calculators have rounding errors sometimes if you get too close. Let me take off 1 decimal point of precision. What the heck is going on here, guys? Somebody find my error. Tell me what my error is here. Usually in a class, I would ask you guys, what have I typed in wrong here? Oh, it's because it's supposed to say 1.999 minus 2. And we see it gets close to point. Let me actually add in that extra 9 I was meaning to, now that I see what my error was. Sorry about this. This was sloppy. And I can see it's getting closer to 0.333333, and we should recognize that as 1/3. So the limit from the left is 1/3. Let's check out the limit from the right. What sort of number should we put in that's a little bit bigger than 2? And hopefully you put in something like 2.001, and when you plug that in, so I'll make my fraction, 2.001 minus 2 over 2.001 squared minus 2.001 minus 2. And it comes out to be 0.3332. And I can tell already that this is also going to 1/3. And since the limit from the left and the limit from the right are both 1/3, the overall limit, so we write the limit as x goes to 2 of m of x is equal to 1/3. So hopefully you're able to write that. Let's take a look at what this graph looks like. Oh, I have some other things in here from another day. Okay, cool. So let's put in this graph of m of x. It's x minus 2 over x squared minus x minus 2. And when I graph it, I can see that as x gets close to 2, I'm going to put the value button. When I put in x equals 2, there is no y value. But when I go just a little bit to the left of 2, when I'm just a little bit to the left of 2, the y value is getting close to a third. And when I'm a little bit to the right of 2, the y value is a third. And I can actually, this is a cool calculator trick to plug in these values in our calculators that we have at school normally. You can put in the function and then press second calc value, and you can type in whatever you want. So I can type in 1.999 and it will automatically plug it in for x, except it gave it to me as a fraction. That's really annoying. Yeah, so it'll give me the y value immediately, which can be a nice trick. There's another trick you can do once you put y equals in here, and that trick is you can press variables, and you go to the y variables, so you press over to the right to go to y variables, and you can pick y1, and what this is doing is it's choosing whatever's in y1, and you can evaluate this like function notation. You can put y1 of like 1.9999, and it will tell you the y value that way. And that way you can like literally not have to type it in a bunch of times. You just put in like, okay, now I want to do y of 2.001, and it'll give you those values. So again, once you type in a function in y equals, you can use that either by pressing second calc and using value on the graph, or you can, on the main screen, press the variables button and go to y variables. So you press over to y values and press enter, and it'll let you pick y1. You can have more than one function in here as well. Okay, guys, with that knowledge, I want you to choose what are some numbers you should be, what is the number that should go in the middle of this table if we're doing the limit as x goes to 0 of cosine of x minus 1. And I guess this is called m of x here, so let's call this m of x. So the number that should go in the middle is 0. And when you put in 0, you should get undefined. Notice this isn't a limit. We're actually like trying to put in the number 0. And so it's a y value, which is undefined, does not exist. And what's a number that we should pick that's slightly to the left of 0? We should put something like negative 0.001. And to the right, we should put what? We should put positive 0.001 or something like that. And so I use a calculator or something to get the answers here. So I'm just going to put in y equals cosine of x minus 1 over x. And I'm going to use the trick on the front screen where I put y1 of, and again, the way you get there is you press variables, y variables, y1, which is where I put it in, y1 of negative 0.001. If you get something like this, 4.99996e negative 4, that means that you need to move, the e negative 4 means move the decimal place 4 places to the right. So this is the same as putting 0.00049999996 or whatever. Like that's what this number is. So recognize this is not a negative number. It's a number that's very close to 0. So 0.000499 or something like that. And this is incredibly close to 0. So it sure looks like the limit is going to 0. If you wanted to pick one number closer to make sure it's not going to like 0.0005, which maybe it is, you know, you could do that. In fact, let's go ahead and do y1 of, we'll go even closer. And now it's 5e negative 6. So when we put in negative 0.00001, this is 0.000005. And we're getting really close to 0. So how do we write this limit? This is the limit as x approaches 0 from the left side, because we're slightly smaller than 0, of m of x equals 0. So this limit is 0. From the right side, you will also get that the limit gets very close to 0. Let's actually plug that in. I like using this calculator trick because it makes it go a lot faster, but you know, if you don't have access to it, there are other ways to do it. And here we get negative 4.999 e negative 4, which is negative 0.000499, whatever. Okay. And so we can see that the limit from the, what is this limit? This is the limit as x approaches 0 from the right of m of x is also equal to 0. So how do we write the overall limit? Well, because they're both going to 0, we get the limit as x goes to 0 of m of x equals 0. So the limit from both sides, as we're getting closer and closer together, the limit is equal to 0. Okay, sometimes limits do not exist. And let's look at why. Let's look at this graph first. Let's look at y equals. If you don't know how to do absolute value, I'll tell you right now, it's in the math button. So if you press math, abs is one way to get to it. So you press math, go over to number, you press to the right once to get to abs. There's some other like buttons up here that you can get to it using the green things. Okay, so absolute value of x over x. Let's take a look at this graph. I want to go make my window go from, so we want to do the limit as x goes to 0. So I want to make my window go from, let's go from -2 to 2, and the y go from -3 to 3, and that'll be good enough. And we can see that this limit does not exist. Why does this limit not exist? And this limit does not exist because the limit as x goes to 0 from the left of absolute value of x over x, which we have to write out because we didn't call, oh, I guess we did call it f of x somewhere. The limit of f of x, that limit as you approach it from the left is equal to -1. But the limit as x approaches 0 from the right is equal to +1. We can see that as you're coming in from the right side, the y values are getting close to +1. And since they don't meet up, since the two limits aren't the same, the overall limit doesn't exist. Here's a different one. F of x equals 1 over x squared. So this one looked like this. And so the limit from the left and the limit from the right weren't the same. This one's super weird. I love it. Y equals, this is one you should almost be familiar with from pre-calculus. Maybe you should be familiar with it. This one has, what's this called? What's happening here? Well, let's actually make my y values go higher so I can see a little bit better. I'm going to make my y values go up to 20. Now we can really see what's going on. It's not like it's going up and meeting at a point. This is what's called an asymptote. And so as we approach 0, the limit, so the limit as x goes to 0 of f of x does not exist because there is no limiting y value. The y values just keep getting higher and higher and higher and higher. One way of saying this is that the limit is infinity, but that's a type of not existing. Because again, what a limit is asking is what is the limiting value? What is the value the y values are getting closer and closer to? And here, the y values aren't getting closer and closer to something. They're just getting bigger and bigger and bigger and bigger forever. So infinity, a limit going to infinity is the same as a type of that limit not having that function not having a limiting value. These are both acceptable answers. The only time I would take off is if it was like a multiple choice. Like you would definitely need to know that it goes to infinity. Okay, and I might give like one more bonus point for this rather than this, because this is a slightly more precise answer of what type of does not exist. And I love this one. I need to make sure my mode is in radian mode, and it is, or this won't work. Let's put y equals sine of 1 over x. And we're going to have to zoom in here because there's some crazy stuff happening in the middle here. So let's zoom in around here. And let's zoom in even more. So what's happening here is that as you get closer and closer to 0, it just like bounces up and down faster and faster and faster. And the closer you get to 0, the more quickly it bounces up and down. And so since there isn't a y value that you're getting closer and closer to, it's just like bouncing up and down. And we can see this if we make a table here. So let's get closer and closer to, I actually don't want to, let's just use like values. So let's do, I already put y equals sine of 1 over x. So, okay, we'll do this here. Well, I'll use these values, that's fine. We're going to put variables, function, y1 of 2 over pi. And that y value is 1. When we do a number that's even closer to 0, 2 over 3 pi, that value is negative 1. When we do 2 over 5 pi, that value is positive 1. And what we'll see is these numbers are getting smaller. And in fact, I'll show you this in just a second. These numbers just keep bouncing back and forth between 1 and negative 1. And so since, so 2 over pi, let's actually look at that decimal value. 2 over pi is this. 2 over 3 pi is this. 2 over 5 pi is this. The y values are getting closer to 0. I can put I don't know, 101 pi. As the y values are, the bigger the denominator is, the closer we're getting to 0. So as we're going towards 0, the limit does not exist because it's bouncing around. So it's got this wave going in as x goes towards 0. So hopefully that gives you a good start on limits. If you have questions, feel free to reach out to me. And your homework should give you some good practice on this stuff. And there's I think I tried to link to just a different guy who I really like, Patrick JMT. He's a guy in Austin who makes videos that people around the country really like. So there's a video link to that for the homework tonight. So practice this stuff. Hopefully you'll start feeling pretty good about it pretty soon. I hope you have a good rest of your day.